To prove the alternate exterior's converse. Prove the alternate exterior angle converse. All right, so as we take a look at that, if I look back to yesterday, because that's when we learned this converse, so flip back to yesterday. These are our converses, so alternate exterior angle says if two lines are cut by a transversal, so that alternate exterior angles are congruent, then we know two lines are parallel. So that's what we're trying to prove. We're going to start by saying that these two angles are congruent, and then we're going to prove that the lines are parallel. Here's the thing about when we're proving this, we can't actually use this theorem to prove it because we're going to try and prove the theorem, meaning we're going to explain why we can do that theorem. So first we need to start with alternate exterior angles. So we're going to draw a little picture. All right, and we're going to be given two exterior angles. So let's just call this angle 1. It's on the outside. So we're going to label the alternate exterior to that angle. So exterior would be on the outside of the other line. Alternate means opposite side, so 2. So we're going to start by saying angle 1 is congruent to angle 2. All right, what we're trying to prove is that those lines are parallel. So we'll call this line A and line B, and we're trying to prove that A is parallel to B. Remember, those two slashes means parallel. Whoa. All right, so who remembers in a proof, how many columns do we do? We have 2 columns, right? One column is our statement. That's our first one. That's our what. And our second column is the reason. That's our why. Nice job. This is going to be a 4-step proof. So if you want to make sure you have 4 lines there. So we're going step by step to prove this. What's our first statement going to be? What are we starting with? The given. Angle 1 is congruent to angle 2. All right, now we know it's 4 steps because I told you it was 4 steps, so you can go ahead and number it if you'd like to. Since we know it's 4 steps, what do we want to end this proof with? A is parallel to B. Nice, Rolena. We don't know the reason, but we do know that that's going to be our ending statement. That's what we're trying to prove. All right, so what we're going to do here is we need to prove that A is parallel to B, and in order to do that, we use our converses we learned yesterday. So I'm going to flip back to yesterday. What we can't do is we can't use the alternate exterior. That's what we're trying to prove. So we need to come up with one of these other ones to help us prove it. If I can prove one of these other ones, then we can say the lines are parallel. So should we work with corresponding angles, alternate interior angles, or consecutive interior? And if we take a look back at the picture, would it be easier to get matching angles, inside angles, or more inside angles? Do we have any inside angles right now? No. So in order to get two inside angles, that would take more steps. So let's do that corresponding. So if I look at angle 2, what would be corresponding to angle 2 over here? Which one of those angles? Kind of the left, right, or the bottom? Which one would match angle 2? Yeah, the bottom, kind of right here. So let's put a 3 there. We're going to add that in. Now I don't know that 2 and 3 are the same yet, because in order to say 2 and 3 are the same, we would need to know they're parallel, but that's our ending spot, is that they're parallel. What I do know about is 1 and 3. What can we say about angle 1 and angle 3? When they're across from each other, that means that they are congruent. So angle 1 is congruent to angle 3. Does anyone remember that theorem that says angle 1 is congruent to angle 3 when they're across? What was the name of angles across?
Linear.
Vertical. Linear is when they're next to each other and they're 180. Across is our vertical angle theorem. You can abbreviate theorem with like THM if you're running out of space. All right, now I know angle 1 is congruent to angle 2. So if I want to make congruent arcs, I can. So angle 1 is congruent to angle 2. Those match. But now I also know we've stated angle 1 is the same as angle 3. So what do I know about all of those angles? They're all the same. They're all congruent because 1 is the same as 2, but 1 is the same as 3. So which 2 have we not paired together yet saying they're the same? 3 and 2. I'm going to go 2 and 3 because that's the way my brain works. Angle 2 is congruent to angle 3. Does anyone remember that one that's like if angle 2 is the same as angle 1, but angle 1 is the same as angle 3, we can skip over that middle? Transitive. Good. So if you need to write that as our little thinking process, you can. If angle 2 is the same as angle 1, angle 1 is the same as angle 3, we skip over from 2 to 3. That's kind of our thought bubble. And that's our transitive property. All right, so for our last step, for step number 4, we have to use step number 3 to prove 4. So 3, we know angle 2 is congruent to angle 3. So now as I look at 2 and 3, what is that relationship between 2 and 3? What kind of angles are they? Alternate interior, alternate exterior, consecutive interior, or corresponding? Yeah, corresponding, they're matching. They're in the same spot. And if we said corresponding angles are congruent, what does that mean? The lines are parallel. So did we say corresponding angles are congruent? Yep, so now they're parallel. So this is the corresponding converse. Sorry, we have to use that word converse. Converse of corresponding angles. All right, we have one more proof that we're going to do. So I'm going to do a little squiggle line here. How beautiful. All right, here's number 2. Number 2, we're going to start off with a picture that we're going to draw together. So again, this one is, as we do this one, you might want to draw it with us so you kind of understand how things are working. So first, we're going to draw 2 lines going this way. Alright, so then we're going to draw 2 more lines. Alright, now we're going to draw 2 more lines. But this time we're going to draw them kind of slanted the other way. So we kind of just made a box, almost. All right, these 2 lines going this way are going to be J and K. And these 2 lines going this way are going to be W, Y. All right, at the intersection of J and W, where they touch, kind of on the inside of the box there is going to be angle 1. Where K and Y touch, we're going to have angle 3. And where J and Y touch at the top, there will be 2. It's almost like the opposite of a baseball diamond. 1, 2, 3. All right, what we're given, we know that J is parallel to K. And we know that angle 1 is congruent to angle 3. What we need to prove is that W is parallel to Y. Alright, so as we take a look at this, again, we're going to have our 2-column proof. This one is 5 steps. A couple of the steps will take more than 1 line, though, so I'm just going to do 1 step at a time. But we have statements and reasons. Hey, how are you? Okay. No, it's just right in. I know, would that be exciting? No, that's not until later. All right, so as we go through this first statement, what is our given? Good. J is parallel to K. I'm going to use some highlighters here because that's going to be really important for us to keep that in mind when we're talking about J is parallel to K. So I'm going to use pink for that one. You can use any color you want, just one color for that one. Highlighters are the ones that are colored all the way through. If you have white on it, that means you're using a whiteboard marker. All right, and what else do we know? What else is in our given? Good. Angle 1 is congruent to angle 3. So if we wanted to mark those, we could with those little arcs. Showing those ones that are across from each other are congruent. Are angle 1 and 3 connected by a transversal? No, they're like an opposite corner, so there's nothing that goes through both of them. So that's the important part to remember. So as we go, that's given. All right, so our next step, this one's like a 5-step problem about, depending on how we do it. I recommend 5 steps is the shortest way. We need to use something from our given to come up with our next step or something from the picture. So based on either the given or the picture, what's our next step that we know? So if I look at line J is parallel to line K, I look at those two. Is there a relationship between an angle from K to an angle in J? If I look at that, I have angle 3. If I follow that transversal of Y, there's 2. What relationship does 3 and 2 have together? Are they alternate exterior, alternate interior, consecutive interior, or corresponding? 2 and 3? If I look between J and K, are they on inside or outside? Inside. It's almost like I'm going to cover up this W. I'm not paying attention to that W. I'm looking at this Y that connects them. So they're on the inside, and are they on the same side as Y or opposite sides of Y? Same side as Y. So if you go back to 3, 2, which one is the same inside? Yeah, consecutive interior. So if I take a look at that one says if I have parallel lines, then the consecutive interior angles are supplementary. Do we have parallel lines? Yep, J is parallel to K. So I know angle 2 and angle 3 are supplementary. So we're going to say measure of angle 2 plus measure of angle 3 equals how many degrees together? They're supplementary. 180. All right, now that's our consecutive interior angle theorem. I'm going to write out that whole word because that's going to be important later on. That this time we're using the theorem. We started with parallel lines, then we said they're supplementary. All right, step number 3, we're going to go back to our given. In our given, we had that angle 1 was congruent to angle 3. But here I want to do an equal sign. So I can't use that congruent sign anymore. I need to make it equals. Can I say angle 1 equals angle 3? Yeah. But what do I have to say instead of just angle 1 equals angle 3? How do I have to write it? I don't just say angle 1 equals angle 3. What do I put in front of that? The m, the measure. We're saying that the number that angle 1 is would match the number of angle 3. So if they're 30 degrees, they're both 30 degrees. If they're 26 degrees, they're both 26 degrees. All right, this is asking you to do a lot to think back to chapter 2. What says that we can go from angle 1 is congruent to angle 3 to now that they're equal? It's that definition of what did we say angle 1 and angle 3 are to start? Congruent. That's what the congruent means. If they're congruent, that means that they are equal. So it's a definition of congruent. Are we doing congruent segments or congruent angles? Angles. All right, so for step number 4, we're going to take this step number 2 and switch out some things. So instead of saying angle 2 plus angle 3 equals 180, we can keep that angle 2 plus, instead of angle 3, what is angle 3 the same as? Angle 1. We said 3 is the same as 1. So now instead of saying 2 plus 3 is 180, we can now say 2 and 1 is 180. So again, back to chapter 2, what says that we can switch something out for an equal amount? Like in soccer, when you switch out a player because they're tired, substitution. Good. I'm doing prop for property, not like prop in a player or musical. All right, so now as I look at 1 and 2, back at our picture, 1 and 2 lie on what line together? What line connects 1 and 2? J. And so they're lying on the same transversal between 1 is on W and 2 is on Y. So I'm going to use again another highlighter, different color this time. So I'll grab a different color. So switch with the partner. I'm going to zoom in here real quick. So originally when we looked at 2 and 3, we were looking between J and K. But now I'm looking between 1 and 2. So I'm really looking between W and Y. What kind of angles are 1 and 2 between W and Y? Are they alternate exterior, alternate interior, consecutive interior, or corresponding? Interior, alternate, or consecutive? Consecutive. Good. So when we have consecutive interior angles, that's those two. They're adding up to 180. If they add up to 180, then the two lines are parallel. So what two lines are we saying is parallel between 1 and 2? W and Y. So W is parallel to Y. And we say the relationship that we just stated. So 1 and 2 are what type of angles again? Consecutive interior. But then we have to decide, is this going to be the theorem or the converse? And that's kind of the big part of these two lessons, is that we need to decide if it's the theorem or the converse. So I'm going to flip back. For theorem, don't put it away yet. Just more part. For theorem says we're starting with parallel lines, then they're supplementary. For the converse, we're saying first they're supplementary, then they're parallel. So as we look at our steps, did we start with parallel and then supplementary, or supplementary then parallel? From 4 to 5. Yeah, we did supplementary first and then parallel. So supplementary first and then parallel, that's our converse. So it's our consecutive interior angle converse. It's almost like that would maybe be on your test. When do you use a converse versus the regular theorem? Okay, converse we use when we're trying to prove that they're parallel. The theorem was when we already had parallel. Then we were proving. Then we said they're add up to 180. Okay, if you wanted to highlight that so it matched your picture, you could. All right, so here is the dealio. Tomorrow we're going to practice these proofs on paper because we're going to need to actually go through and see if you got what it takes. It's going to be exciting. So today we have